Question 4 brings us into the realm of waves. So we have some water waves going into a harbor. Question 1, or question I guess A1, AI, wants us to draw 3 wave crests in the harbor. So notice that the word 3 is underlined, well, bolded. So make sure you follow that instruction. But also notice that nowhere in the question is there a change in depth. So because it doesn't tell us that the depth changes, we must assume that the depth is constant. And so even while having diffraction happen, as is the case when you squeeze through a gap, my wavelength is not going to change because my depth has not changed. So make sure that when you draw your 3 crests that are like circular in nature, that your wavelengths are approximately the same wavelength as that from the incoming waves, because there is no change in depth. It is part of the mark scheme. It is also just scientifically correct. Remember, we're not just doing it to be pretty. The fact that there is no change in depth means that the waves must be close together. If you're not too sure about your waves, try using a pencil always. I am personally going to move mine a little bit because they are not great. So this is the kind of thing that you would want to do using a pencil so that you can then adjust and make it the right distance from each other. Then we are introduced a different harbor. We don't have an image of it, but we are told that it has a wider gap. Now, if it has a wider gap, that means that the energy from my crests doesn't have to squeeze quite as tightly and therefore will not spread quite as sharply. So most of my waves are actually going to pass straight through. So when it says description is just telling me what happens, or you telling me really what happens. So what happens is that the waves pass mostly straight, or they don't curve as much, or something along the lines of that. And the reason why they pass mostly straight is that a larger gap means there is less diffraction. You really do want to use the word diffraction here, because that is the phenomena that determines whether or not your waves are going to curve. And then for the last bit, it's just a speed calculation. So we know that a sound wave has an 850 hertz frequency in seawater, and in that same seawater we know the speed. I'm just going to highlight so we can keep track of our very important information. We're trying to find the wavelength. So wavelength, frequency, and speed. Thankfully, I know an equation that has all 3 of those variables. So I'm just going to write it down. And that's speed equals frequency times wavelength. I've written it backwards to what I've said it, but same thing. And then I'm just going to put in what I know. I know my speed. I don't know my wavelength, and I know my frequency. And now I'm just going to solve for lambda. So that's 1500 divided by 850. And I end up with a wavelength of 1.8. Because it's wavelength, I'm looking at units of meters. And there's your 2 marks. Just showing the work using the equation and getting the right number with the right units.